I would like to know how do you rate the need of sharing the knowledge in between thermal and acoustic aspects?
It's a very important topic. As I mentioned in my presentation, I learned it personally sitting in an environment in an office with rather poor or non-existing acoustic measurements, because typically, it's often a question of cost. So during the planning phase of a project or of buildings, what I've learned so far is people or a lot of work is done into designing the thermal systems, but when it comes to acoustics, there are not that many planning tools available. There are not that many experts, or you can ask. So typically it's something that's not really implemented in the design phase, and buildings are somehow constructed, but it's learning by doing, or it's applied later on if you encounter some troubles with acoustics, or if you hear complaints, but it's nothing that's really an integral part of the planning process. And so, I found this very interesting, bringing people together from these two areas to talk to each other and to understand each other, what the needs for this.
So this is the challenge. I call that maybe a leakage of integral planning. So you got experts in the thermal field and acoustic field, but how do they touch each other during a planning phase in a project?
For now, typically, if there is not a demand or something negotiated beforehand that acoustics play in a role, or that there is not a definition beforehand, that's typically something, that's not taken care of. Only in an environment where it's that could be in schools, or that could be in office spaces where on very high quality, where you define comfort and acoustic comfort levels beforehand, but nothing that's typically done in a daily practice.
Yeah. When I was listening to the speeches today, we saw that there is a kind of fear when you want to add acoustic tiles underneath, let's say, a concrete activated ceiling, because of shading them. So, and you talked in your speech about the 4 boundaries for primary energy analysis. Do you see in the control and in the power of the end user potential in optimizing the taps efficiency?
Yeah, it's a bit of, that's again, we have the problem. I'm coming from that field of optimizing, or we have that, let's see, view on systems purely on the thermal design. And so typically we analyzing or we identifying optimization potential only for the thermal part of it. And of course, when we are talking about TAP systems or thermally activated building systems, we need, from a thermal side, we need as much accessible thermal mass as possible, and everything that's in our way, of course, is lowering the efficiency of these areas or of these systems. The optimization potential we found that came up in our analysis is more on the hydraulic side. So it's more on minimizing energy for pumps, so minimizing auxiliary energy to as little as possible. To be honest, the questions from an acoustic side, how we have to implement this, or what impact this has on our systems, that's a fairly new field, to be honest.
Yeah. My last question would be maybe in 1 or 2 sentences, on what topic do you work at the moment at the Fraunhofer-Institut?
Right now, my personal project is one larger project is a refurbishment of a school campus. So a school consisting of several buildings from different ages. So we have new buildings built to passive house standard, 2 buildings that are built in the early 1900s. So where you have the Denkmalschutz. Yes. I don't know that in English. So that's one of the important projects I'm currently working on. Yeah.
Okay, thank you very much.